we are Diana,
Monse, and Christy.
and welcome to our video.
Today, we're going to talk about systems of linear equations.
That's right, but before we start, let's learn the basics of our topic.
Let's start learning!
For a better understanding of this topic, we need to know the basic concepts of it. First, what is a linear equation? Well, let me tell you. A linear equation is made up of two variables, just like any other equation, but no variable is raised to a power greater than 1. Its base form is y equals mx plus b. You might find this very useful when you want to find the distance or time during a race.
But what is a system of linear equations?
Don't worry, Diana, let me explain it.
A system of linear equations is a set of equations that we can work with at the same time. It's when two or more equations are coexisting. The solution of the system is a point or a set of points that make both equations true. The solutions are represented as ordered pairs, x, y. Here is an example. A system with two different equations. Graphing the system, it would look like this. Two equations that intercept in 2, y as an ordered pair. This type of system is known as consistent independent, but I know there are more types of systems of linear equations.
Christy!
Hi, Monse.
Hi! Can you help us with the types of systems?
Sure, as Monse said.
The types of system of linear equations. The first one is the consistent independent, which has at least one solution, which is the crossing point. The next one is the inconsistent system, which is same line because both equations have the inclination and the same y-intercept, which means infinite solutions, and the consistent dependent, which are parallels because they have the same slope and different y-intercepts. For solving the system, we need to consider that y is the same, so the next step is to rewrite for equalizing the functions and then isolating x. Now, for finding y, we need to evaluate in any of both functions according to the x value we got. Both of them will be the same. So, the final crossing point will be 1/2, 7. Problem time!
Now that we have covered all the basics, let's start solving some more advanced problems. The problem is: Dion will rent a car for the weekend. You can choose one of the two plans. His first plan has an initial fee of $57 and costs an additional 11 cents per mile driven. The second plan has an initial fee of $50 and costs an additional 13 cents per mile driven.
And the questions are, for what amount of driving do the two plans cost the same? What is the cost when the two plans cost the same? And what is the best plan?
Let's start solving, but first, let's know more about the concept common cost.
Common cost is a shared expense of creating a product or providing a service between companies.
Let's write the first equation of the first plan. First, we know that an additional $0.11 per mile driven is added to the cost. So let's use x to represent the number of miles, meaning that x is multiplying 0.11. Then it is clear that $57 will remain alone because it is the initial fee.
Huh? Where am I? Oh yes. The second equation is the same. 50 is left alone, while 0.13 is accompanied by x. Don't forget that this is an equation and needs to be equal to y. For what amount of driving do the two plans cost the same?
In order to answer the first question, we need to solve for x. We equalize both of the equations because we are looking for the amount of miles during a common cost. We then isolate x by passing them to one side of the equation and the rest of the values to the other. Now that we did this, we just simplify to get x, which is 350 miles.
What is the cost when the two plans cost the same?
Now that we have the number of miles, we can find the common cost. We know that the common cost happens when x equals 350 miles. So, in order to get the result, we need to substitute with the value of x. The result in both of the equations is $95.5.
What is the best plan? It's really simple. We just need to substitute by some number, and we choose 2. So we substitute x for 2 for evaluating and isolate y. And according to 2, this is the answer for the second plan. Now, for the second one, we do exactly the same thing. We choose 2 for evaluating for x, and we isolate y. And this will be the answer for the first plan.
Now that we evaluated, we know that the best plan is the second one because it is cheaper.
Thanks for watching!